There we go. So hi, everyone. My name is Courtney. I'm the Career Service Advisor here at NYC Data Science Academy. I see some familiar faces, and I truly thank you guys for joining us today. I also would like to thank Brendan for joining us today. He is the founder of Makepath, and he will be the one doing the presentation. But before we actually get started with his presentation, I would like to do an introductory to the NYC Data Academy. So let me share my screen, just so that you guys, if you're not familiar with our program, you will get familiar with our program. Does everybody see my screen? Thumbs up? Yes, awesome. Okay. So again, everybody, welcome. We are New York City Data Science Academy. We are a boot camp. If you would like to share your thoughts, please just make sure that all your mics are muted, and make sure that when you're in the chat that you're sharing everything with all the panelists and attendees, okay? So about the school, so data science, so we offer the boot camp and courses. We are the only boot camp teaching both Python and R. We have hands-on learning in 4 industry projects that you complete while you're in our program, and you'll actually have the opportunity to present them on your blog to show in your portfolio, which is very important when you meet with me, to showcase to hiring managers what it is that you've completed. And that's what pretty much the gist of this presentation is how can we build our portfolio so that we are more marketable to hiring managers. We also offer job placement support, which is what I do. I work very closely with about 28, 29 people currently, and my goal is just to help you guys find a job in this market. Currently, we have over 2,000 alumni working across the globe. We literally have people everywhere. We are very big on making connections with our alumni and connecting people to help you guys develop in the industry. And we were rated as the best data science bootcamp and best online data science bootcamp by switchup.org. I think that's very important. So just a heads up, we do have 2 upcoming boot camps. So we offer Remote Live, which is a 3-month program. That one begins July 8th. We plan on going back to the academy starting July 8th, July 6th. We plan on going back to the academy, and we will be open. And this will be our first course being taught in person since last March when we shut down because of COVID. If you're not able to begin the summer session in July, we are also offering a session in September 27th as well for the fall. We also offer full-time online boot camp, which is a 4-month program, and a part-time online boot camp, which is a 6-month, and that also too starts July 6th. So we're doing both in person and online. And if you're interested in that, please feel free to apply. So the admission process, you submit an application, and then you'll have an interview with one of our people from admissions, and then there's a tech assessment. Currently, we have a discount running for 10% off, which is $1,760. And this early bird discount expires June 18th. So definitely jump on that if you're interested in applying. And if you have any questions, please feel free to reach out to admissions at NYCDSA.com. They will gladly be able to help you with any questions that you have. I don't work in admissions, but I will definitely be including my email in the chat box if anybody has any questions about the career service support that we offer. So that is the end of my spiel. So I am going to give Brendan, where are you, Brendan? There you go. I'm going to give Brendan, he's now going to be the host. And I'm just going to take a step back because I'm going to be learning from you too, Brendan, because I don't know anything about data science. I tell all the students that I meet, I know nothing about it. So I'm like entering your world. So I'm very interested to hear what you will be presenting today.
Great. Well, thank you, and thanks to NYC Data Science Academy and for having me here. It's one of the things that I do is trying to get the word out around different open source projects. And let me go ahead and share my screen here. Are folks able to see the Makepath homepage right now? You should see visualize what's hiding in your geospatial data.
Yes, you're good.
Okay, great. So my name is Brendan Collins. I'm the co-founder and principal at Makepath. We're a spatial data science company based in Austin, Texas, with a passion for open source. We take open source projects and we help clients solve difficult problems using free and open source tools, which we think are the best tools around to be using to solve problems. And this is makepath.com, just a shameless plug for our company. You can also learn more about some of the projects that we work on at the makepath.com blog /blog here, which reviews some of the things that we're passionate about and the client projects that we're working on and some of the other open source projects that we're working on. And so I got into data science through open source contribution. So this is my GitHub page, and for a long time served as my resume. So as I went around to find projects to work on and also jobs in the past, GitHub has served as a good resource to show prospective hiring managers what I had done in the past, and also some of my work. So actually being able to see code that I've written and projects that I've contributed to. GitHub was a real catalyst for my career in software and in data science. And it was a great opportunity to be able to find projects and then find areas within those projects that I was passionate about doing open source contribution. It can be a little intimidating starting on a large project with a lot of other contributors, but I have a particular passion for geospatial data and understanding the question of where and how we can use computers and computational geography to better understand the world. So some of the projects that I'm currently working heavily on include X-Array Spatial, which I'm the creator of and maintainer of this library, which we'll talk about for image analysis, and then also the bokeh data visualization library, which is for generating rich interactive visualizations using Python, which target the web browser. We're not going to be going too deep into that, but know that bokeh is one of the premier data viz libraries for Python, which I've been a core contributor on since 2015. And then I'm also one of the creators of Data Shader, which is a rasterization engine, and we can talk a little bit about Data Shader, that helps us find structure in large data sets. I'm also the creator of the King JSON Bible. If anyone's interested in doing natural language processing on the Bible, you can check out the King JSON Bible. But I wanted to talk a little bit about first the applications of data science and how we apply data science to real world problems. Here, I just brought up a project that Makepath built for a company called Sylvia Terra. Sylvia Terra is creating something called NCAPX, which is a carbon credit exchange platform. So when we think about climate change and a lot of the global challenges that we have, being able to put a price tag on carbon is important to be able to capture the value of both trees that are currently not being cut down to sequester carbon. And what this application is doing, this is a React.js front end with a Python backend. It's helping buyers of carbon credits understand the impact of what they've done. So the idea is that if you're emitting carbon dioxide, say from a factory, and you want to offset your carbon emissions, you can create a contract with somebody that controls or has a stand of trees. A stand is just a unit of trees, to not cut down those trees and instead use them as carbon offsets. So those trees have some amount of carbon dioxide sequestered inside of the tree, and keeping that tree alive will make it so it sequesters more carbon, and then also allows those companies to hit their carbon emission goals. So we're looking at some of these projects that have been going on, and this application is focused for a single buyer, say someone like T-Mobile, who's offset some of their carbon emissions through buying carbon credits. So that's one area that we work in a lot, is natural resource management and environmental protection and conservation. Another area that we're working in heavily is retail. So here we're looking at a foot traffic comparison dashboard. And what this is there's a company called SafeGraph, and they provide point of interest information for tons of different locations. And some of the values that they provide, or data that they provide, includes how many people are coming in and out of a given store. This information is taken from cell phone towers and other sources and then aggregated by SafeGraph, and you can purchase their data. Now, since they're a pure data company, they need to be able to tell their story. And that's where Makepath came in to build a rich front-end application, which allows us to first select a metro area. Here in this dropdown, we're looking at Chicago. Then also select a retail vertical. Here we're looking at coffee and snack bars. And then we can pin different brands head to head and see who is winning in terms of foot traffic for specific census block groups. So here, as I look at Kendall County, we can see that in the foot traffic, about 33% of the foot traffic is going to Starbucks, and 2/3 of that traffic is going to Dunkin', or what was Dunkin' Donuts. So this is a simple but powerful application to show the value of SafeGraph data to buyers, and that's what we were contracted for, was to be able to tell the story of SafeGraph data and why it's important, and allow people to explore the data before they potentially purchase it. But I'm really here to talk not about these front ends, but talk about the back end of Python. And so I love Python for web programming, but then we heavily use Python for data analytics. And for those that aren't familiar with Python, Python was created by Guido van Rossum, who wanted to create a programming language to teach programming to children. So this is a very approachable language. While it does take time to learn any language, Python is a valuable one to learn because it is both has a simple syntax and has the breadth of use cases. So everything from web programming to data analytics and others, but specifically the web and analysis has taken off for Python. And you may not realize, but one of the websites that was built using Python that many of us use was YouTube. So behind the YouTube front end was about 1 million lines of Python to do things like load the videos and transcode them, and everything that has to do with video processing. A lot of that was coordinated with Python. Other websites that were created using Python include Pinterest. I'm trying to think of a lot of the news sites. So if we think about like the Washington Post, Django is a popular web framework for Python that was created specifically for large news organizations that wanted to deploy small applications quickly. So Python has a huge presence on the web side. I'm going to be talking about Python on the data analytics side, where it's become one of the premier languages for artificial intelligence and machine learning. And I really like Python for geospatial analysis. I'm going to show you guys some of my favorite libraries. I'm hoping that that folks walk away from this presentation with a good idea of stuff that they can explore in the future. If you're brand new to Python, I've never used it before, I'm hoping that there'll be some content here for you. And if you're an experienced Python developer, we also have some material that goes a little deeper into using some of the libraries that we're going to cover. Now, when it says that Python is powerful and fast, plays well with others. So that's talking a little bit about some marketing for the language. Python by many people is considered actually a slow language in terms of performance. And part of why it's considered slow is that when you compare it to languages like C or C++, you'll see an order of magnitude decrease in actual code execution speed. And I want to talk a little bit about that performance. Now, but on the other side, when we think of programmer productivity, Python, you can write, say, the hello world for Python, which is print hello world, in one line, where the hello world for C++ is like 20 lines, where you're importing a standard IO library and you're setting up a class with a constructor. And so the overhead to learning C++ and developing in C++ has made languages like Python and R and Ruby, PHP popular, because you can get to a finished product faster than you can with languages like C++ or Java or C. So Python fills an interesting niche in the programming world of being both, a systems programming language and also a shell scripting language that kind of sits between those two. But there's this issue of programmer productivity versus performance is one of those key trade-offs that we think about when using Python. And many times I'll go and I'll be talking to someone and they'd say, oh, we'd never use Python for that. That would just be way too slow. But as time has gone on, Python has created some libraries that actually make the language run at a similar order of magnitude as C or C++. Ultimately, C Python is the Python that we all tend to use. That means that the Python language was actually implemented in C, and there are other variants of Python where we have a version of Python that's implemented in Java and a version of Python that's even implemented in Python. Wrap your head around that one. But I'm going to talk a little bit about performance and some of the libraries that we want to know as we think about Python as a data science language. The first and core library that I want to talk about is a library called Numpy. Numpy is as it says here, is a fundamental package for scientific computing with Python. It came out of the Mayo Clinic for biomedical imaging purposes. And the idea behind Numpy is to create an n-dimensional array structure. So an n-dimensional array is a multi-dimensional array. So we can think of one-dimensional list. We can think of 2 dimensions as a list of lists. And then as we keep going n dimensions, we can have 3 dimensions, 4 dimensions, hundreds of dimensions, all together in a single array data structure. So the Numpy is a fundamental package for the reason that it provides a contiguous block of memory to do operations on that is strongly typed. And to talk a little bit about performance on Python, there's a major reason why Python code many times is slow, and that is type checking. So when we create a list in Python, which is a heterogeneous container, when we're looping through that list, on every element, we have to ask the question, what type of data is this? Is this a string? Is this a numeric value like an int or a float? Is it another object like a dictionary or a list? So the reason why Python is slow is because it's dynamically typed. You don't need to define your types up front, but that makes it so the Python interpreter, which runs all your code, needs to check every element constantly. That's where Numpy comes in. So what Numpy provides with this n-dimensional array is a homogeneous typed structure where the Python interpreter does not need to look at each element to figure out what type of data it's operating on. So instead, we have a contiguous chunk of memory that's strongly typed of fixed length, and then we have a bunch of helper functions on top of it. So when we think of Numpy, we're thinking of 2 different things. We're thinking of an n-dimensional array container and a collection of functions that operate on top of that array container. And that's what Numpy is. So Numpy is one of the core dependencies for many of the other data science libraries, including libraries like TensorFlow. If you guys have heard of TensorFlow from Google and machine learning, PyTorch and others on the AI side. And then we've based a lot of our open source tools on Numpy. So this presentation is like from the fire hose. You're going to get hit with a lot of information here, and I'm sure that there's going to be some eyes that are glossing over this stuff and thinking, oh man, I don't know what Brennan's talking about right now. But I just hope that you at least get to know what some of these packages are, and then you're able to go deeper into how to use these packages on your own time. So I'm going to be reviewing a bunch of packages, but they start here with Numpy. As we look down, so in working with tabular data, that's a very common data science task, is you get something equivalent to an Excel worksheet. So an Excel worksheet is one tab with an Excel workbook. Pandas wraps Numpy arrays to give you a tabular data structure called a data frame, and R also has a data frame. I believe that Pandas kind of stole the idea from R, but Pandas is a fundamental library for dealing with tabular data. That means that the Pandas data frame inherently understands rows and columns. So if we're looping through data using Pandas, we don't need to refer to first loop through all the rows and then loop through all the columns. We can simply address a Pandas data frame, and we're going to be seeing some examples as we go along. So this idea of Pandas is that we're adding labels onto NumPy arrays. So generally when we're using NumPy, we're going to index the NumPy array using integer locations, a lot like you would in Excel, where you're saying, hey, A5 plus B4. But what if A had a real column name instead of just a letter? Like say A was something like total price, and we could refer to that column by that name. It would make the code much more readable. And that's what Pandas is essentially adding, is that it gives you a tabular data frame with labeled columns so that your code is actually readable in 4 months. So, or actually in 4 hours, depending on the type of code that you're creating. Now, if we know that NumPy is n-dimensional, it's not just 2-dimensional. Pandas is 2-dimensional, rows and columns. If we want to go to n-dimensional labeled arrays, there's an interesting library called Xarray. So Xarray is similar to Pandas in the idea that it wraps NumPy and it adds labels on top of columns. This library Xarray can add labels in n dimensions. So if we want to stack data up, say we have a bunch of images that are represented as NumPy arrays, that's a very common way to represent an image in memory in Python, is as a 2D NumPy array or a 3D NumPy array, depending on the content of the image. With Xarray, we can add labels on top of our dimensions. So Xarray is a really interesting library, especially if you're getting involved in climate data processing. That's really what it was made for, and that's the area that I'm very passionate about. So looking at Xarray is a good library for dealing with n-dimensional images. Numba, and this is from the fire hose, so excuse me if I go too deep into any of these topics. Numba is a just-in-time compiler for Python. So where we find tight loops, and I define tight loop as an area of your code that has not particularly that much logic, but executes many times. So if we think of looping over all the pixels in a large image, that would be a tight loop. And in the past, this would be the type of operation that you would not want to use Python for, because it would be slow, because it'd be type checking on every iteration. Numba is a library that allows us to write Python code that we put a Python decorator on that says, compile this code to LLVM bytecode, or the machine code that's run by a C interpreter, a C compiler. So Numba is one of those key dependencies that we use all the time at Makepath to speed up our code. and to also target different hardware configurations, things like CPUs versus GPUs. So Numba is, I think, a really fascinating library, and we're going to see a little bit more Numba as we go. When this little control thing goes away, I think I'll be able to hit another tab. Oh, there we go. So when we think about scaling and performance and big data within data science, Numba represents our vertical scaling. So we want to make, in vertical scaling, we're thinking about making our algorithms faster. So what I do a lot is implement first in, say, just pure Python and see how it runs, and then add on a Numba decorator to see if I can get additional performance. And sometimes that performance can be anywhere from 10x to 100x performance improvement when using Numba. But this is vertical scaling. So we're taking an algorithm and we're making it faster. Horizontal scaling within our tool stack is done using Dask. So in horizontal scaling, we're thinking about being able to run our algorithms on many threads or many cores or many machines. So when we want to take say we've made an algorithm fast and now we want to run it on 1,000 machines coordinated at once, Dask is how we would do that. And Dask makes its way into a lot of our projects at Makepath, and we're currently working with Microsoft and their planetary computer to deploy open source tools using Dask on clusters. So say we have a petabyte of satellite imagery and we want to do a vegetation analysis on that, Dask would be a good solution to be able to use 1,000 commodity machines on Amazon or Google Cloud, or excuse me, I should say Azure, because I'm now working with Microsoft, so I gotta speak the language right. So yeah, so you're running on Azure, then Dask is a great solution for that horizontal scaling of taking an algorithm or a function and running it across a large cluster of machines. In this case, we're breaking Dask implements a Dask array that is composed of several small NumPy arrays. So here again, NumPy is coming in. NumPy is one of those just really core dependencies inside of Python that has empowered the data science applications for Python. Now, so I'm super interested in geospatial data. So geospatial data has two different types, really fundamentally, of geospatial data. One is called raster data. Raster is all about images and regularly gridded data sets. So like when we think about the world and we think about the phenomena in the world that we want to represent inside of a computer, it's going to fall into either raster data or vector data. And in other disciplines, say like in graphic design, we have this same thing. So there's a program called Adobe Photoshop. Adobe Photoshop is a raster editor at its core. There's also Adobe Illustrator, which is a vector editor at its core. And so this dichotomy between raster and vector is also represented, applies to the real world in terms of continuous phenomena and discrete phenomena. So raster data is appropriate for representing things, or raster format is appropriate for representing things that are continuous across the landscape. So things like rainfall, elevation, soil types can even be a raster. So this is where like we don't have discrete areas where, just to contrast that so you guys understand, with vector data, I'll probably take my calendar off. So in vector data, we're dealing with discrete phenomena, things that can be represented as points, lines, or polygons. So things like the county boundaries, that is a vector. Things like rainfall, like I said, is a raster. It's hard to draw a polygon around rainfall to measure it. It's better represented as a grid where you have the amount of rainfall in each cell, and then you have specified a resolution for your grid. And this back and forth between vector and raster is one of the things that I think about a lot, of how we convert our vectors into rasters, how we convert our rasters into vectors. What type is most appropriate for representing a phenomenon that I'm interested in. But in terms of my open source work, I focus a lot on the raster side, and X-Array Spatial is a library that fell out of Datashader that we created at Makepath and then we continue to maintain. There are tons of great open source geo tools. So at Makepath, we made an infographic that shows vector and raster tools starting from the early 70s that go through some popular projects that you may want to know about if you're interested in geospatial data analysis. And each one of these areas would give you a small description of what this project is and who created it so that you can learn more. And so you can go through this, and this infographic itself is an open source project. So if you've heard or you've seen a new geospatial library that we don't know about, that's open and free to use, then please, you can go over to the GitHub for this infographic, and you can add it in, and it can be a community-driven infographic to promote open source geospatial projects. And Zoom is going to go away in one sec. So the project that I want to go deep in, so that was a high-level overview of some of the libraries that you should know about: NumPy, Pandas, Xarray, Numba, Dask. These are composed what is the PyData ecosystem, which are tools within Python that are all open source for data scientists and the scientific community in general. So Xarray Spatial, like I said, is a raster analysis library for Python. And what it does is it implements common geospatial functionality on top of Xarray and NumPy using Numba and Dask, those the vertical scaling library and the horizontal scaling library. So what we're going to look at are tools that you can run over clusters. So you can coordinate operations across many machines to gain the power of, say, if you wanted to create a single computer that had, I don't know, like 5 terabytes, 10 terabytes of RAM, then that would be somewhat difficult. But you could rent a ton of machines on Amazon that each one has, say, 16 gigs of RAM, and then you could coordinate work across all those libraries, all those machines, and that's what Dask is doing. And we implement algorithms that will scale with Dask and Numba. So some of the areas that you're going to see here within Xarray Spatial include 1D classification tools. So these are things where you have a 1D array and you're classifying it and binning data into different categories. So things like equal interval classification and quantile classification. So when we're doing equal interval, every bin that we bin our data into is going to have the same width by definition of equal interval. While on quantile, we're going to have the same number of values in each bin. Natural breaks, where we think about minimizing the standard deviation in any bin. So these are pretty classic 1D classification tools that geospatial folks tend to know and use in their desktop packages. Focal tools are tools where we can run and look and analyze the area around a pixel. So a smoothing filter would be an example of this. To smooth an image, what you can do is you can pass a kernel, which is defining a neighborhood around each pixel, to recalculate the values of each pixel, say taking the mean. So if you're going to look at a pixel, look at the area around it, calculate the mean value of all the values around that pixel and assign that output in the new output image. That's a lot of what focal tools are looking at doing. Hotspots is an example of where we would look at the statistics within a neighborhood and look at the difference between the statistics at the global level to find statistically significant hotspots and cool spots. Now, when we look across this table of features, we're going to see that there's a bunch of different array backends. So the Xarray data array, so Xarray, right, is adding labels on top of NumPy arrays, can support multiple different types of arrays. So we have our NumPy array that's going to execute on a single machine. So this is just going to be in memory on your workstation. The Dask array, which is can run across a cluster of machines or can run with many cores on your local machine. The CuPy array is for CUDA-enabled GPUs. So when we think of the GPU to help in number crunching, and specifically CUDA, which are NVIDIA GPUs, we have support for NVIDIA GPUs here, and then we're still building out support depending on the module for clusters of GPUs. So if we want to coordinate many GPUs together, then this is what this column for the tool represents. And if it has a green check mark, then that means that this tool is supported within the project. Multi-spectral tools are for doing classic band arithmetic in satellite imagery. So as we look at the classic one is NDVI. So NDVI will help pull out vegetation, things that are living within an image, by looking at the ratio between red and near infrared within a satellite image. So these are fairly classic multispectral analysis tools. Pathfinding is about finding the least cost path through an image. So say we're thinking about, say we had an image that represented a road network for a city and we wanted to route from one pixel to another. A-star pathfinding is a good way to do that, and that's currently just supported for Numpy. Proximity is all about distance, and so being able to create distance grids. Then we have terrain analysis tools and some zone tools. But I want to show you guys some examples of how this is used. So I've come over to so here on X-ray Spatial Makepath, github.com Makepath X-ray Spatial is the GitHub page here. We actually had a release this morning, so we just have a new release out. And you can come over to examples and to the user guide, and you can find some Jupyter notebooks that will help you understand how to use X-ray Spatial and give you some examples to work from. So here we're looking at some surface analysis tools. Make this a little bigger so folks can see. And this is just a guide to using some surface analysis tools within the Jupyter notebook, and then also shows some Python. So here we're doing our imports, and we're going to start by generating some fake terrain data so that we don't have to go out and get a separate data set to do analysis on. So here I'm generating, using Perlin noise, some data that is going to represent elevation as we go through doing some surface analysis. This is using data shader and X-ray spatial together. So this output image gets added right into the notebook. And we can start by just adding a color map onto the terrain. So I'm using a somewhat pseudo elevation color map so that we can highlight areas within our fake terrain that appear to be higher or lower, and symbolize that using a appropriate color map. Now we can start using some of the tools from X-ray Spatial, like Hillshade. Hillshade will illuminate the terrain using a light source at a given altitude and azimuth. So we call the Hillshade function on terrain. We get a new array back, and then we shade that array from gray to white with a alpha or transparency, and a how, which is saying how do we stretch these colors across the values? Do we do it in a linear way? Some other options would be to do it using a log function or a cubed root. So there's different ways that you can stretch these colors. So right now we're just using a linear stretch. And then we can composite these two layers together. So I'm now taking the color mapped elevation and stacking it with our illuminated terrain to start to get like a pseudo 3D feel for what this terrain looks like in this our mythical island place here. So some surface analysis tools like slope. Slope is going to calculate the first derivative of the elevation. So we're looking at you know, the steepness in any pixel, and then using Numpy, we're going to do a thresholding operation and look at only those pixels which have a slope greater than 25 or less than 50 in kind of a pseudo avalanche analysis. So if you can resolve the red pixels here, these are pixels that we've pulled out of the image of saying that they have a risk of avalanche. Curvature is the second derivative of elevation, which would be like the acceleration down the surface, or also the concave or convexness of the surface. We're not going to talk too much about that. But aspect is looking at the direction that the hill is facing. So is it facing north or west or east, and you can pull that information out, which has a lot of applications for agriculture and also things like avalanche, where if you have slopes that are facing a certain direction, then that can increase that potential. Viewshed is all about line of sight. So asking the question here, we're going to set up a scenario. So here in this image, we have an observer in orange, and then we have a fake hill. And I've applied the illuminate so we can kind of get that pseudo 3D feel of understanding the depth here. And what we want to do is we want to highlight every pixel that is in direct line of sight to this user, to this observer, and the direction the observer would have to look to actually see that. So now I'm running the viewshed function. This has been imported from Xarray Spatial. And then we're highlighting all of these pixels in red that we're able to directly see line of sight from this observer. And then you can see some pixels that you should intuitively understand wouldn't be seen because they're either on the back side of this hill or they're being blocked by this hill, so we can't see them. So we can apply this hill shade on top of the terrain, but I think you guys get the idea. So here on top of our mythical terrain, we have our observer on this slope in the middle, and then we can pull out all the pixels from the terrain that this observer would be able to see line of sight. And the fun part about this is that all this code that we're doing is all publicly available and transparent, so you can dig into exactly how we do this by going to the Xarray Spatial GitHub page. Proximity tools are all about distance. And so here in proximity tools, I'm setting up a pandas data frame with a couple of columns with X and Y and an ID. And these are to represent different point locations. So starting with this image here, we have a bunch of different point locations, and we want to generate a distance grid where each pixel would indicate the distance to the nearest point. So as we run this proximity, I'll probably didn't run these cells up here. We'll run a couple of these, probably help the cause. So I've called the proximity function on our points array. I've specified some target values and the max distance. And what we get back is a distance grid where we can see that these values, as the color green becomes lighter, that would be closer to the point. So we can see some natural breaks where we're closer to one point or another. These are really, really helpful for machine learning, where you're trying to do feature engineering to generate new columns or new dimensions of data to feed to your learning algorithms. So if you want, for instance, like distance to nearest supermarket, you could put the supermarkets as your locations, and then you could generate distance grids and add that to your data before you start training any of your machine learning models. So we're doing some more proximity here, and we're changing the distance metric of how we actually calculate the distance. And these apply not just to points, but also lines and polygons and any other feature that you may have inside of a image. So here I'm doing proximity to this line, so we can see some of the natural, what you'd make out as either being closer to this part of the line or other parts of the line. And you can transform that proximity. So here I'm achieving a buffer by thresholding a proximity grid and creating a buffer outside of our out of our image using Numpy and Xarray. Proximity allocation is all about which point you're closest to. So instead of putting the distance to the point as the cell value, we're putting the ID of the point as the cell value. And that's what proximity allocation is about, so that we can say, hey, all of these pixels are closest to this point. All of these pixels are closest to that point. And then finally, just to talk about proximity direction. So instead of putting inside of the output cell value, instead of putting the distance to the point or the point's ID, we're putting the bearing or direction to the point. So we're saying, hey, this pixel here has a bearing to the nearest point of, say, let's just say 300 or something, whatever this value would be in 0 to 360. So this is a look at some of these spatial tools. There's additional user guide notebooks that you can dig into. And certainly I'd encourage anybody of any skill level to get involved in open source. Great ways to get involved in open source include helping with documentation. If you're new to data science and to programming and you want to get involved in open source, documentation, testing, reviewing issues, those are the types of things that you can do without having to go too deep into code. If you're not quite at that level where you feel like you can contribute on the code front, there's still a place for you in open source. And you can ramp up on your skills as you make contributions to, say, testing new features in the library, or helping with documenting and creating examples of how to use the library. So I'd encourage anyone of any skill level to contribute to open source projects that you're passionate about. So if there's a certain area, say you're really interested in astronomy or in health sciences, there's tons of different projects out there on GitHub and other sites that you can find where there's communities of people organized to create free and open software around that topic. So this is a zonal notebook where we're calculating stats by zones. So we're doing summary statistics by zones within the image. When you dig into the code here, so I want to give a little time for questions and just general conversation, but what I would do a lot is I would come over to XArray Spatial and then look inside of XR Spatial, and we can look at something like the slope function. So if we want to understand how slope was calculated, we can just open up slope and we can read it. So we can read the math behind how you calculate slope or how we're calculating it. And then you can come back and you can say, hey, I don't like that, or yeah, that's awesome. But also you can use these as templates for your own functions. So as you think about looping through an image and doing something, you can say, hey, I'm gonna check out XArray Spatial. I'm gonna copy and paste some code from XArray Spatial and then modify it for my own purposes. And this shows some examples, for instance. So here's the CPU version of slope, but contained in the same file is the GPU version of slope. So when we're running this on a GPU instead of a CPU, we have a slightly different implementation for that, and that's available here within the code. And you can see how we structure our library, how we document things. So reading code is really great. I like to nerd out even further by actually even rewriting libraries. So like I'll take someone else's code library and I'll just write it. I'll write it the same way that they wrote it. And that might seem like a little extreme to do, like say to just take this file and write it by hand, but it gets the code into my fingers. Through doing that, I learn a lot about how other people code and how they develop things. And it's an easy thing to do where I don't need the library to work. I'm not thinking about how to implement something. I'm literally just taking lines and rewriting them and like brute forcing code into my brain. And that's one of the things that I've been doing for a while that I just enjoy. It's just a relaxing process for me to take someone else's code and rewrite it and just basically transcribe it. It's like transcribing music or something. And to learn more about Makepath and what we do, I'd encourage you to check out the Makepath blog, where we show some of the different events that we have going on and projects that we're working on. And also you can get information, for instance, about upcoming AI and ML events and conferences. So this is a place that we actively put our ideas and announcements. But I wanted to just generally open things up to see if folks had any questions about what I presented. I certainly presented a lot at a very high level. So thanks for your patience as you know, is pretty from the fire hose on a lot of these topics. And so happy to answer any questions folks have, although I haven't looked at the chat there. But please speak up, or you know, or we can have someone, you know, read out some of the things. I'm going to this chat here, which looks like there's maybe some questions going through.
Yes. I know David answered a couple of them. One question that wasn't answered was Python backend or Netlify? Or Netlify?
Yeah, so you know, Netlify is a great platform for deploying Python applications. I consider it a lot like Heroku. I've been using it for some projects, like the Sylvia Terra project, for instance, that I showed with the Carbon dashboard is deployed using Netlify, but it's still running a Python backend. And like you can deploy your own servers, but there is some overhead to learning what people refer to as DevOps these days, or the coordination of those servers, having to log in, apply patches, making sure that the server software is up to date. So there's overhead in doing the administration side of running your own server. So things like Netlify and Heroku and AWS Lambda, and there's a lot of different solutions for deploying these applications in an easy way. So yeah, I mean, Netlify has been great for us, but I also love Heroku and some other platforms for deploying Python web apps.
And anybody else have any questions? You can unmute yourself and speak, or you can write in the chat box and I can speak on your behalf. No?
There's so one thing I'd like to highlight is in September, FOSS4G, which is the free and open source software for Geo conference, is coming up. We're sponsoring that conference. It's a great opportunity to interface with other folks in the open source geo world for anyone that's interested in geospatial technology. And then there's a lot of different events that are going on. And while we've had the whole COVID pandemic stuff going on, there's a lot of these are now available virtually, so you can attend those conferences or check them out on YouTube. Last week there was the Dask Summit, so I was showing Dask, which was for the horizontal scaling of coordinating clusters of machines. All the content for the Dask Summit is on YouTube now, so that's a great source of material. I feed my family on GitHub stars, so I encourage folks to go to github.com/makepath/xarray spatial and give me a GitHub star. That's a great way to keep my children fed. So thank you for that. But also, feel free to reach out to me on GitHub or on other places. I don't really use any other social media besides GitHub, but I'm available to also help in getting people reviews on pull requests or helping point people in the direction of good issues to work on. So be thinking about that. And I encourage everyone to find an open source project that you're passionate about, that you can make contributions to. And I'll tell you that you'll get out of that experience more than you'll put into it. Like you do a little bit and you learn, and you're going to learn a ton by contributing to an open source project. So encourage you guys to do that.
So there were a couple of questions that popped up in the chat. The first one is, you mentioned getting involved with open source via testing or writing documentation. How do you recommend actually starting that journey? Like, what would be the first step? Should you reach out to someone who contributes to say a library you want to work on?
Yeah, I mean, there is, I think there's a side which is just, to quote a popular shoe brand, like just do it, like getting in there, looking at issues, trying to find issues that are appropriate for first-time contributors. Many projects will put a little label on issues and it says, good for first-time contributor. So I also look at the number of contributors in a project, not just the popularity in terms of stars, but how many other people are contributing to this library. And that's a good indication of how easy it will be to become a contributor. And it can be frustrating. Sometimes you do some work and you submit a pull request to a library and no one ever looks at it, and you kind of have to speak up. And so there's all of the issues that come up in working in a decentralized kind of collaborative project come in on any project. So there are challenges there, but I think that just having an open attitude to learning and to understanding that you're going to make mistakes. People are going to say, hey, like, I don't think this is appropriate for the project, and understanding, okay, that's fine. Maybe I'll start my own project. That's what happened with Xarray Spatial. I kept adding things to another library and they were like, Brendan, please stop. Like, thank you for this, but like, if you want to keep doing this, just create your own library. And so that's what I did. I just created a new library that had the code that was focused on what I was interested in, and then promoted that. And so, you know, there's give and take, but I think that it's really fun to interface with folks that you've never met across the world on a project that you're both passionate about. So that's awesome. And it's huge when you go into an interview for a new job and they say, so tell me about your experience. You say, well, I'm a core contributor to an open source project that your company is using, you know? So it's like, how much does that validate you to a place when they're already using your software that you're contributing to? And that's a big part of like my journey through being a freelancer into running my own agency. It was about that open source contribution. And so I worked alongside of Samsung for a while because they were using Datashader, and they said, hey, we want a core dev from Datashader. So they didn't ask me like, hey, show me your degree. They said, like, we know your GitHub commits, like we know who you are because we're using one of the libraries that you're working on. So that's a really big boost in terms of being able to get a job and also negotiate in that job, is saying like, hey, I'm connected to this community and I can help connect you guys in here and support one of the core dependencies to your mission.
Awesome. Another question is, where did it go? Sorry. Any healthcare open source projects that you are impressed by?
Well, there's certainly a lot of projects that are applied to healthcare. So pandas and like something like Keras and scikit-learn on the ML side, those are applied to healthcare problems all the time. So we're taking, when we think of data science in the three areas of mathematics, hacking skills, like being on a computer, and then applying it to a domain, healthcare is then your domain. But if you're solid on the math and on the computer science skills, then you can take those skills and apply them to almost any domain. So there's a lot of different projects out there. Health Landscape is a really, really interesting site where I believe it was the Academy of Family Physicians put together a intensive data page so that you could get information about, for instance, minority underserved health areas, all the census demographics tied in, to be able to get that information and do analysis on it. I was recently looking at the topic of pharmacy deserts, of trying to find areas that had reduced access to pharmacies. Looking at that and looking at, okay, where do we have a disproportionate number of senior citizens without access to pharmacy services? And that was something that I did a blog post on a little while ago, and that was kind of a topic really to use our tools applied to a real world case. So there's huge opportunity on the healthcare side. Obviously, there is HIPAA. So when you think about data science and healthcare, HIPAA comes up like right off the bat. So the folks that are going into the next level of healthcare data science should start getting familiar with what HIPAA is and how to be HIPAA compliant.
You don't want to violate anybody's rights.
Yes.
So Matt had a question. He states, I missed some of the beginning. Could you quickly describe how you suggest finding specific topics for your open sources projects?
I mean, I think it comes from your own passion for different areas. So if there's a domain or something that you want to learn, that you say, hey, like I want to find, I love the geospatial stuff. And so I got into that because I was passionate about environmental protection and conservation, and saw that domain needed like more computer science skills. So I wanted to go into computers really to get back to forestry and some of those other topics that I was passionate about, and found that as a path. So I think there's looking kind of at your own passions of what topic would sustain you contributing to long term. Like if it's not the first week, what happens in 2 years from now? Is that something that you're still going to be interested in and willing to invest your nights and weekends on? So that's that's one of those key areas. And also finding organizations that value open source contribution. so that you can maintain things and have it not just be nights and weekends. It's nights and weekends for a lot of folks, but then there's companies, Makepath is one of them, that actually sponsors open source devs for people to work full time just on open source. And that's a whole other presentation on how you actually figure out a business model to do that. But it's a great area, and it's fun and collaborative, and it also, like, when you're working on open source projects, you're not limited geographically. So I work with people that are in Brazil and Vietnam and India and Europe, and we can all come together on tools because those tools are free and open and don't have the burden of like expensive license fees that would limit folks in areas to contribute.
Anyone has any further questions? No more questions? I don't think so, Brendan, but I would like to sincerely thank you so much for coming and joining us and presenting today. Again, if you guys need any information, you can definitely reach out to me, and I can definitely pass it off to Brendan if you need. You said for them to reach out to you through GitHub, right?
Yeah, GitHub would be a great place. You can also, feel free to email me at brendan@makepath.com. Is another place you can send an email and say what's up. But yeah, thank you so much to NYC Data Science Academy, and look forward to collaborating on things in the future.
Yes, we definitely will. But thank you guys. Thank you guys for joining us, and have a great, awesome day and enjoy the rest of your week. Thank you guys.